forgot to record my 2 lessons this morning, so we're going to start here. Again, I'm just going to put slide 3 up here. We talked about the fact that the second one would be tougher to climb because it's a little steeper. And anytime we're at the base of a hill and we go up to the right, that is considered a positive slope. And now students are responding to the question of number 4 on slide 4. Even if they love skiing and snowboarding and are a beast at it, which one might be a little bit more unnerving? Now, this one, and this is the case, when you're at the top of a hill or something like that and you're going to come down it, that is actually considered a negative slope. For those of you who, yes, that's Frankie barking. For those of you who are also like active bikers, what's that called? Cross off-roading or cross something? Cross, like bike cross, motocross, it's like bikes. Anyway, you come down hills, it's that same idea. So those are negative slopes. All right, let's look at slide 5. Hey, no. No. Frankie, no. All right, so take a look at those 2 sets of staircases, the one on the top and the one on the bottom. Which one do you think would be, which one is steeper? And then also, which is an example of positive, would stairs be an example of positive or negative slope? So 2 questions for you to answer. Which staircase is steeper, and are they positive or negative? All right, some of you aren't quite on the right slide, so I just sent a message to the whole class. Many of you are on here, so thank you very much for that. Again, which of these stairs is an example, which is steeper, and then are these an example of positive or negative slope? I'm going to see what you responded. Yes, the second one is steeper. I like that description, angled up higher. Ooh, yes, both. You can choose to go up or down. Who is that one? Jacqueline, that's correct. And, you know, the perspective of, oh, interesting, Ashley. The perspective of if they are positive or negative slopes depends on where you're standing, right? Because if I am at the bottom of a staircase and I have to climb up, that is a positive slope. But if I'm at the top of the staircase and I need to go down, that is a negative slope. So staircases can actually be both. All right, let's take a look at slide 6. All right, you get to get a new phone. And that new phone is going to cost $750 without even activating the line or getting service for it. Then you find out that it's also going to cost $30 a month to keep your phone active and to have it as service. What is the rate you pay per month? Go. What is the rate you pay per month? Doug's looking at me like I'm nuts. Well, so here's the thing. A lot of times people will buy their phone outright, right? And then you have to pay each month a certain fee in order to keep the data running on your phone. So it doesn't technically, the answer to this question doesn't matter about how long you're going to use that particular phone and that service provider. So again, look at the problem. If you're not sure, reread the question. The answer to the question is actually in the problem. What are you going to pay per month? ESA IDK is not an answer in this one. Reread the problem. What are you paying per month? Says it in the problem, folks. You pay $750, and like, let's say you go to Best Buy and you're like, yep, I just am going to buy that phone. I'm not going to activate it yet. You pay $750. Then you decide, okay, like I'm going to go, I don't know what you guys use, but we use Verizon. So I'm going to contact Verizon and say, I've got this new phone and I need to find out how much it's going to cost me per month to keep it active. Okay, that's what the $30 is. So what is the rate you pay per month? And if you go back up and look at the problem, you have to pay $30 per month for service. There's your answer. You should have 30 in here for that. So when we talk about slope, we talk about rate, how fast something happens, how much you have to pay, how much you have to pay back, how much you make babysitting, how much do you make when you go out and clean off the driveway, either shoveling or snow blowing, right? 30, 30, 30, 30. All right. Take a look at slide 7. Noah, you did way more for that problem than you needed to, but thank you for figuring that out. All right, slide 7 wants to know, says this. So a mother and a daughter are at the beach. They've decided they're going to run a race, a 100-yard race. The daughter runs at an average of 2 yards per second, and mom runs an average of 5 yards per second. Two yards per second and 5 yards per second. So what are their rates? A rate means how fast somebody moves, how fast you pay something, how much you pay, how often you visit somewhere. Okay, so as you look at it, the daughter runs an average of 2 yards every second, and the mother runs an average of 5 yards every second. So what are their rates? Careful, Noah. Not how long will it take them to finish the race. All it is what are their rates? How fast do they go? So you should be saying for the daughter to fix that answer, you guys. Hey, how fast do they go, you guys? How fast does the daughter go? Look at the problem. How fast does she go? The daughter runs at an average of 2 yards every second. The mother runs at an average of 5 yards every second. Fix those answers. Thank you. Fix those answers. Thank you. Yes, Ashley, thank you. Isa, thank you for fixing that. No, Adrian, not 25 and 20. Our brains froze over the weekend. Yes, Maddie, 2 yards for the daughter, 5 yards per second for the mother. Those are their rates. So when we talk about rates, folks, it's how fast something happens or how slow something happens. Okay, so the daughter goes at 2 yards per second. Mom is 5 yards per second. That is what we call the rate, how fast or how slow something happens. The rate at which you type, if you've taken keyboarding class ever, the number of words per minute, that is a rate, okay? Rate and slope are the exact same thing. Now, if you look at slide 8, we can take what we know about their rate and we can show that actually on a graph. So move up to slide 8, please. And this is the one slide where I'm going to ask you to flip over to the Google Meet so you can see what this is asking. So here's what this is asking. We can take a look at their rates actually in a graph. We know that the mom goes at a rate of 5 yards per second. If you were at the middle school last year, you worked a lot on rates. That's like the main 7th grade standard, is dealing with both unit rates and then using, oh my goodness, the terminology just making common fractions, a proportion. Okay, so we know that mom goes 5 yards every second. And we can show that in the graph. So we know that at time 0, so before the race has even started, mom is at a distance of 0. I know that as I go over 1 second, mom will go a distance of 5. So some of you actually with the previous one were asking or trying to figure out how long it would take to finish and whatever else that may be, but that wasn't the question. Okay, it was just about the rate. So I know after 1 second, mom goes 5 meters. After 2 seconds, mom will at yards. Mom will be at 10 yards. After 3 seconds, mom will be at 15 yards. So we can see that slope, that rate over 1, up 5, over 1, up 5, over 1, up 5. Ooh, terrible line. All right. On your slide 8, I will keep my slide up there. On your slide 8, I want you to copy my slide onto your slide 8. Go. So she's laying down somewhere. Not happy at me for telling her to stop barking. All right, so you're going to have to just do a little flipping back and forth. That doesn't help me just by you saying I don't get this no more. That doesn't help. Ask a question. Ask a clarifying question. What is it that you're not understanding? Again, you should be flipping back and forth between my slide 8 and your slide 8. And you are simply copying the graph that I have on my slide 8 and you're putting it on your slide 8. Frankie, stop barking. No. No. No bark. Nope. No. Good. I see a lot of you have it. Whoops, I'm muted. Good. I see a lot of you are doing what I've asked you to do. Again, we know that mom goes at a rate of 5 yards per second. And so we can show that for every 1 second she goes on in the race, she goes a distance of 5 yards. After 2 yards, she goes 10. After 3 yards, she goes 15. If we were to continue that graph, then she would go 4 seconds, 20 yards, and so on. All right, once you have copied that one onto your own slide, you can actually go back to your Desmos and stay on your Desmos. Go ahead and flip, switch up to slide 9. Switch over to slide 9. And Isa, I'm not trying to be rude about that, but instead of saying I don't get it, if you can ask a clarifying question, that helps me figure out how to help clarify. All right, so when we talk about slope, rate, steepness, and slope all mean the same thing. So notice I've got a graph here on this page that shows you both a positive slope and a negative slope. Take a moment and tell me what's one observation you see between those two graphs. Here. You can't get the cookie. Get the cookie. All right, so again, taking a look at slide 9, you are giving me one observation that you notice between the positive slope and the negative slope. Yes, Karina. Good. Yeah, you know what, Brenda, one thing I do want to point out to you, if you look at that positive graph, or actually the lines, you guys see how there's arrows on the ends of those lines? That actually means those lines can keep going. And while the negative slope, or excuse me, while the positive slope graph looks like it's only in the positive portion of it, if we expanded this graph out, it would actually, the positive one would continue going down to the left into that negative part. So the picture is a little misleading. The big takeaway that I wanted you to have here about slope is that the positive slope goes up to the right and the negative slope goes down to the right. Okay, think of it as walking up a hill or walking down a hill. Those are the two things. All right. Yes, they're going in different directions, exactly. All right, let's take a look at slide 10. So there's nothing for you to write on slide 10, but if you take a look at it, please. All right, so if we take a look at it, there's this person standing right here at the edge of this cliff. We're not going to go skiing down the edge of that cliff, right? Because that is just not a good thing. That anytime you deal with a line that is straight up and down, We call that slope undefined. Okay, it is an undefined slope. Now, if we take a look at slide 11, this one's a little bit different. The ground is really flat. Not super exciting in terms of skiing and too much excitement. Yes, cross-country skiing is very good exercise, but in terms of the excitement factor, that's going to be a horizontal line, okay? We call this slope absolutely flat. We call that a slope of 0. There's no steepness for it, okay? So anytime you need to refer to anything about slope, my suggestion is you come back and take a look at slides 9, 10, and 11. Those are going to give you those key ideas for slope. Now, let's take a look at slide 12. This is where we're going to talk about y-intercept. Noah, Jefferson, and Aiden, we're on slide 12, please. Maddie, Isa, slide 12. Martez, slide 12, please. So sometimes when you are having a race, it's fair to have everyone start from the same place. And then sometimes it's okay to give somebody a head start. When might you give somebody a head start? Type your response in that section. Go. When might you give somebody a head start? When might you give somebody a head start? Oh, they might be tired. Good thought. Somebody's younger, less capable. Yep, somebody might be disadvantaged. Exactly. Like if you got in a race with Mrs. Gifford, you'd give her a head start. For sure. For sure. Okay. Now, speaking of that head start and going back to that mother and daughter, now let's look at slide 13. All right, so in slide 13, we're going back to talk about that mother and daughter who are at the beach and going to have that race. We know that the race is going to be 100 yards long, and we know the daughter will go at 2 yards per second, and mom goes 5 yards per second. Because of this, mom decides to let the daughter to have a 45-yard head start. What are their starting amounts? Mom does not get a head start. The daughter does. Fill in your response in that box. Go. Go. What are their starting amounts? Meaning, where are they starting in terms of that race? You should have 2 answers for this one, just like you had 2 answers for the rate question about them. You're going to have 1 for the daughter, and you should have 1 for the mom. Oh, Jacqueline, way to use coordinate pairs. Good idea. Yes, Natalie, that is right. Martez, yes. Aiden, correct. Karina, I can't remember if I said your answer. Yes, that's correct. Aiden, Martez, Jacqueline, Natalie. Brenda, not quite at 22 yards. All I want to know is where they're starting. You're giving me their rate again. So remember that when you start, one of you hasn't gone any distance whatsoever. So your starting value is at 0. So mom is actually at 0 yards. Or, like I said, Jacqueline put the coordinate pairs. And the daughter got a 45-yard head start. So you would say she is at 45, or if you're going to put that as a coordinate pair, you're going to put 0, 45. Okay, very simple. I'm not asking you to figure out how long it would take, who's going to win, where do they meet up, none of those questions. All I wanted to know was their starting value. So that's what it means for starting value as y-intercept. So now if we take a look at slide 14, please. Slide 14 shows this picture of a diving platform. And you've got different levels of the diving platform, and then you've got 2 diving boards that are called springboards. And in this one, I just want to know, where would you be willing to jump from? The height of a penguin, which is about the height of a table, so that's 1 meter, the height of an ostrich, the height of an elephant, if you stack 3 dolphins on top of each other, or 2 giraffes. What starting point would you feel comfortable with jumping from? What starting height would you be okay to jump or dive from? Just curious. When I was growing up, yeah. When I was growing up, I would have been that 10-meter person, that person jumping off of this. I wouldn't do anything fancy. I would jump off of it, but I wouldn't do any dives or any flips or anything. But I would definitely have gone up there and jumped down. Okay, no judging, by the way, because I don't know if I would do that now as an in my age. All right. So that's the y-intercept. Those are considered the starting values. Let's go back to slide 15. We're going to talk about the cell phone problem now. Again, go back to that cell phone problem. So again, we have to get another new phone. Another new phone is going to cost $750. And then you have to pay $30 every month to keep that data plan activated. What is the initial amount you pay? Meaning, what do you start with? How much do you pay to start off? Before you even activate the phone, you have to pay for the phone, right? So what are you going to pay? Careful, not $30. You're not going to buy the phone for $30. Yeah, it's going to be $750, right? You have to pay $750 just to get the phone, and that doesn't include activation. Okay, so in here, the starting value for slide 15, you should call that $750. So y-intercept is the same as the starting value. Y-intercept is always the coordinate pair 0, something. That being said, take a look at slide 16 now and tell me what you think. Go. So it's 2 questions with this one. What is the y-intercept, and why do you think we call that the y-intercept? You should be on your Desmos. You don't need my screen up. What is the y-intercept of this graph? Based on what we talked about in 15, 14, 13, and 12. Remember, it's the starting value. It's the starting value. Initial amount, y-intercept. Good. Yep, it's at 50. All right, thank you for your honesty. Not really sure why. Okay, here's what I can tell you. This is why it's called the y-intercept. Those of you who are familiar with football, okay, you know that when somebody intercepts a pass, the ball is in the air and that person comes through and catches the ball in the line of the path, right? So the y-intercept is where a line crosses this y-axis. So we call this point right here, when a dot is on the line, we call that the y-intercept, okay? Good job using that coordinate pair, folks. I'm also okay with the number 50. The reason why it's 50 is it's right directly between the 40 and the 60, okay? Now, that's the lesson for today. Your assignment is actually going to be to finish up through slide number 25, which it includes the reflection. And then if you get done before class is over, I want you to take a look at your lesson 1 and lesson 2 Desmos or your grades to figure out if they are complete or not. If you see a score of 2.36, you did not complete the Desmos. If you see a score of 4, your Desmos is completed. Okay, so again, you are finishing this Desmos 3 as the end of your assignment here. So you have access to the rest of the slides. Go ahead and keep working. If you have questions, I've got GoGuardian open, or you can drop them in the chat here.